Okay, so in this video I'll be going over converting numbers in base 10 to binary. So let's say we've got the number 58, I suppose, in base 10. This little subscript is notation for base 10. So let's say we want to get this thing into base or binary or base 2. So the way we're going to look at it is in base 10 we have these positions here. This is the 10 to the 0th slot, 10 to the first, 10 squared, and so on. And over here, if you have the decimal place, blah, 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 we'll have 10 to the negative first, 10 to the negative squared, and so on. So for our example here, 58, we're going to have an 8 here and a 5 here, because we have 8 times 10 to the 0. 10 to the 0 is just 1, so 8 times 1 is that 8. And then we've got the 50, which is 5 times 10 to the first, or 5 times 10. So binary, the way binary is going to work is we're still going to have these little slots, except now we're going to think of it as this. We're going to have 2 to the 0, 2 to the first, 2 squared, 2 to the third, and so on. So instead of it being like over here in base 10, 1, 10, 100, so on, we're going to have 1, 2, 4, 8, 2 to the fourth is going to be 16, and so on. So you can already kind of tell binary numbers tend to be a little larger than base 10. So if we're going to do this, the way I do it, the way I was taught, there's another way, I'm not entirely sure how it works, is I'll go all the way out until I reach a number that's larger than the number I'm trying to convert. So since we can go bigger than 16, I'm going to go out to 2 to the 5th, which is 32. And then I'll do one more out, so 2 to the 6th, 64. So we already know there's going to be a 0 in this slot, and you don't even have to write this 0, technically. So we can kind of get rid of this one. So we're going to be starting here at this 32. And so this should all fill in into 58 perfectly. So we're going to have a 1 here because we have 132 that fits into 58. And so the way you can kind of do this is you can take 58, subtract 32 on the side, and you're going to get 26. So, and then you check, does the next number go in? So does 16 go into 26? It does, so we'll put a 1 here. So now we'll subtract 16 from this, and we'll get 10. Does 8 fit into 10? It sure does, so we'll put another 1 there. Subtract 8 off of that, and then we're left with 2. So does 4 go into 2? It doesn't, so we'll put a 0. Does 2 go into 2? It sure does. So we'll put a 1 here. And then since now we've got nothing left, everything else is just going to be a 0. So 58 base 10 is equal to 1, 1, 1, 0, 1, 0 in binary. So that's how you convert from base 10 to binary. So let's try doing it the other way around. Let's try going from binary to base 10. So let's say we've got the number, I don't know, 1, 1, 0, 0, 1, 1, sure, in base 2. And we want to convert this into base 10. So first thing I'm going to look at is I want to figure out what all these, how far out this goes. So I'm going to space this out a little bit. So here's 2 to the 0, here's 2 to the first, 2 squared, 2 to the third, and all the way out to 2 to the 5th. So we know we've got 1 here, we've got 2 here, 0, 0, so 2 to the 4th is, 4, 8, 16, and then 2 to the 5th is 32. So really all we have to do is add all this stuff together. So we're going to get 48, 50, so 51. This is equivalent to 51. And you could do this the way I went with the way we did it from going to decimal or well decimal or base 10 to binary, and we could lay this out like this. We could have the um, here's 10 to the 0, here's 10 to the first, and here's 10 squared. 10 squared is 100, so we know it's not going to go to there. 10 to the first. Uh-oh. Oh, wait, no, never mind. 10 to the first, so we're going to have 5 of these. I was scared because I thought we were still in binary. I thought we couldn't go over 1, but since we're in decimal, we can go all the way up to 9. And so that's 50, and so now we have just 1 left over here. And so that's how you would could do it that way too. But I think it's easier if you just add this stuff up, since when you add it, it's already in decimal. So that's converting between binary and base 10.